Assalamualaikum and hi, my name is Muhammad Shafiq bin AZMAN. I'll be presenting about group project for utilization of electrical energy. So for our company name is Goodyear Energy. Okay, so this is our team members. This first one is me, Muhammad Shafiq bin AZMAN. The second one is Muhammad Zaryf bin ZIMAN. And then Muhammad NIZAM bin ZAHARI. MARIAH binti Muhammad ZALUDIN. The last one is Muhammad SHAFIQ bin RAHMAN. Okay, we move to introduction. So for this project, our company will build a bungalow residential area at Bandar Baru Bangi, Selangor. The construction area has been carefully chosen to avoid unfavorable outcomes such as landslide and areas that are too steep, which can cause the house to collapse. The main important issue is to create an electrical system design that can implement the energy efficiency such as cost-effective and others using available device of software. The success of making this housing estate a sustainable energy source will meet the needs of government, which wants the goal of sustainable energy achieved in the 11 Malaysia Plan, future planning. Okay, now this is our organization chart. So our company name is Goodyear Energy Sendirian Berhad. Okay, and the motto is you can survive without power. So Muhammad Shafiq bin Abdul Rahman is our chief executive officer, and besides him is Mariah binti Muhammad Zaludiin as executive secretary, and Muhammad Zaryf is director of project management, and me as a director operator, and the last one is Muhammad NIZAM as a senior engineer too. Okay, now we move to objective. There is 3 objectives. So the first one is to propose suitable site location and choose the suitable type of building for the new housing development. The second one is to design single line diagram and floor plan for a low-cost single-story bungalow house by using 2D sketch drawing. And the last one is to prove the proposed electrical system design implemented the energy efficiency, such as cost-effective and others. Okay, for the scope of these projects, the first one is the design is a single story bungalow residential house. The second one is maximum demand, costing and other related calculation is based on the proposed design of single story bungalow house. And the last one of this scope is the engineering innovation proposed and applied is done to minimize energy consumption. I think that's all for me. We move to our others members. Thank you.
My name is MARIAH binti Muhammad ZALUDIN, and I'm going to present about the electrical floor plan drawing. In this drawing, we have a 5 ceiling fan, which is locally at every room. Fluorescent lamp, we have 8, which is locally at every part of the room. And we put 2 at the living room because it covers a huge space. And the chandelier lamp, we put 1 at the living room. And globe lamp, we put 2. Flammant lamp, we put 4. Wall globe lamp, we put 1 only. And 15 horsepower air conditioner, we put 2, which is at living room and master bedroom. Water heater, we put 2, it is locally at both toilets. And the huge part of this drawing is 13 ampere socket outlet, which is we put 24 of them. And fan regulator, we put 5. The distribution board, we put 1 at the entrance of the house. And finally, we put 22 of the one-way switch. So this is the single line diagram drawing, which is we refer to our notes before. For this part, the maximum demand for sustainable efficient diagram. For example, I explained about the fluorescent lamp. So basically, there are 8 lamps and the watt is 9 watts. To get the total current load, the quantity must times the watt. So 8 times 9 is 72. And the demand factor is 0.6 as it is fixed range. And to get the maximum demand, total current load must time with demand factor, which is 72 times 0.6, and we get 43.2. So next calculation will be explained for the next slide.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zaryf bin ZIMAN. So in this slide, I will continue about the calculation for maximum demand for sustainable efficient design. So from the past slide, we get our total maximum demand, which is 7,516.4. So from total maximum demand, we will get our maximum demand by times it to incident factor. Our co-incident factor is 0.9. So after times the total maximum demand with co-incident factor, we will get our answer for maximum demand, which is 6,764.76 watt. So from maximum demand, we divide it to 240 times 0.85, we will get our maximum current, which is the answer is 33.161 ampere. From maximum current, if we times it to 1.25, we will get our total estimate current, which is 41.451 ampere.
Alright, seterusnya kita akan terus kepada load consumption for sustainable efficiency design. Okay, kat sini kita boleh lihat electrical appliance, yang mana kat sini ada LED globe lamp, fluorescence lamp, ceiling fans, wall globe lamp, aircon, and then filament lamp, water heater point, LED, and then 2 outlet socket 3 ampere. So kat sini ini adalah kata quotation yang mana kita buat kira-kira dahulu sebelum kita go through untuk kita applykan dekat housing. And then kat sini kita tengok quantity, and then total capacity, so kita kena tahu berapa, and then total connected load. Okay, contohnya macam untuk aircon load dia berapa, and then hours of users, maksudnya berapa jam yang kita boleh gunakan untuk setiap item tu. And then last sekali kita akan totalkan consumption, and then last sekali kita akan dapat jumlah total dia. Ini adalah kata kiraan yang mana untuk per day, and then kiraan untuk total dalam masa 1 bulan. Okay, so macam yang tadi tu adalah bentuk table mana kita akan pecahkan berapa kita dapatkan jumlah, and then last sekali jumlah dia berapa. Okay, kat sini kita tengok setiap kata elektrik yang kita guna tu kita mesti adalah divide dengan 1000. So kat sini yang mana 57266 adalah jumlah yang tadi kita dapat dalam table, and then kita akan dividekan dengan 1000, dia akan jumlah dia akan dapat 57.26 kilowatt. So dekat sini yang untuk jawapan yang akhir ni, yang mana 30 hari ni untuk 1 bulan, elektrika yang kita guna adalah 546.78 kilowatt. Itu saja.
Assalamualaikum, my name is NIZAM bin ZAHARI. Today I will present about the maximum demand for unsustainable design. For example, we can see incandescent global lamp and incandescent chandelier lamp is unsustainable design. The unsustainable design choices can lead to higher operation cost over time, and inefficient building may require more energy for heating and cooling, resulting is increased energy bill. Next, for the next slide, we need to calculate the maximum demand for unsustainable. Then we need to calculate the maximum current and estimate the current. Then we need to select the protecting for current rating. Then we select the 68 ampere rating. Then for the next slide, the total for load consumption for unsustainable is 59105 watts, and we need to total the electrical usage. We must divide 1000 to get the total electricity for 30 days. Next, for the cost estimation, we need to calculate because the rating is different. For first 200 kilowatt, next for 100 kilowatt, and next for 300 kilowatt in per month. Then the total all must we pay is 1262.3.
Assalamualaikum. For our analysis and discussion, we moving on to our analysis first. Bandar Baru Bangi, Selangor has been chosen as the appropriate location for good year energy housing project, principally because of its convenient accessibility to a variety of store and public services. Goodyear Energy places a high value on implementing sustainable practices into a design of their homes as an environmentally conscious business. LED globe lamps and chandelier lamps has been thoughtfully incorporated into the homes and the search of energy efficiency and aesthetic appeal. So for our discussion is the Bandar Baru housing project by Goodyear Energy place a strong emphasis on comfort, safety, sustainability, and accessibility. They are committed to providing residents with convenience, as evident by the handy location and close-by amenities. Utilizing environmentally friendly techniques and technology, such as LED globe and chandelier lamps, for both energy efficiency and aesthetic appeal. They give sustainability top priority.
In conclusion, Goodyear Energy has proposed Bangi Selangor as a potential location for the plant. In the neighborhood, there are a lot of shops as well as public. Additionally, the business chooses a construction style that is suitable for the creation of the new neighborhood. The organization selected a location that is friendly to the surrounding environment and appealing to those who value tranquility. Following that, the business designed a new housing by putting in LED globe lamp and chandelier lamp respectively. The firm designed environmentally friendly homes at theme that yet provide their owner with level of comfort. As we can see, this conclusion is about the standard for design housing, and then to make sure it's safe to use. Okay, that's all for me. Thank you.